So, on the class opener, you want to solve this inequality? Let's get x by itself on one side. You have x's on both sides, so let's get rid of one of them. I'm going to subtract the 3x to get rid of it, and what I do to one side, I do to the other side. So I will have a negative 1x minus 4 is greater than, and I bring down the positive 7 right there. So I need to get x by itself. What would I do next? Add 4. Thank you. Add 4 to both sides, and you're going to have a negative 1x is greater than, that is 11. Final step. Divide by negative 1, divide by negative 1. We should all know that when we're dividing by a negative, what do we have to do with that inequality? Flip it, and you end up with a negative 11. And ladies and gentlemen, that's our answer. X is less than negative 11. Let's move on. So we're moving on to section 5.4, compound inequalities. What is a compound inequality? It's simply two inequalities written together, right? Well, technically they could be written together, or they could be written together, but they're still separate with the word or between it, okay? So that's what I'm saying right here. The compound inequality can be written together or apart with the word or, but it's still considered a compound inequality. It'll make sense in a little while once we go over some examples. Let's graph some of the compound inequalities to understand them better. Well, we have, see this right here, we call this a compound inequality because it's really giving you two inequalities at once. They give you this, and let's graph that. What would we do? We'd go to the x value of negative 3, which is right here. Let me actually do this. Okay, and is it going to be a solid dot or an open dot based on this inequality? It's going to be an open dot at negative 3. And what does this say? It says x is what compared to negative 3? X is what? Less than, right? Right? It's opening up to the negative 3. That means negative 3 is greater, but we want to talk about x. So x is less than negative 3. So which way is less than? To the left or to the right? To the left. Less than is to the left. And that is my graph of that part of my compound inequality. Let's go to the other part. Compound inequality is just two inequalities thrown at you at the same time. So the other one, let me do the other one. Actually, I probably should have underlined it blue since I did that graph in blue. Let me underline the other one in red. The other one says x is greater than or equal to 1. So let's go to the value of 1. And am I going to put a solid dot right here at 1 or an open dot? Solid, because it has a solid line underneath the inequality right there. Okay. Now, again, what does it say? It says x is what compared to 1? X is greater than 1. So greater than, does it go to the left or to the right? To the right. And ladies and gentlemen, we have graphed our compound inequality. It's really just putting both graphs on the same number line. Any questions? Let's look at this next example. This is another compound inequality. This one's written a little stranger though because it's truly written together, okay? We have x in the middle, and then we have a number on the outside and a number on the outside. So what we need to do is focus in on one at a time. Let me do this. Let me get this red block right here. Let me cover that up. So what does that inequality look like? What does it say? X is less than 1. Okay, so let's go to 1. Negative 4, negative 3, negative 2, negative 1, 0, 1. And am I going to put an open dot or a closed dot right there? Open, because it does not have a solid line underneath it. So it's not going to be a solid dot. And when we think about what we see right there, it's saying x is what compared to 1? X is less than. So is this going to the left or to the right? Less than is to the left. They both start with an L, okay? So we did that part of the compound inequality. Now let me move this box, and now let me cover up what I already graphed, and let's read what we see right there. Now, in this case, it's a little strange because we're going to have to read this backwards. We're going to have to read this x is what compared to negative 2? X is what compared to negative 2? Greater than, it's opening up to the x, so x is greater than negative 2. So let me go to the negative 2 value. Am I going to put an open dot or a solid dot right there? solid because of the solid line that we see right here underneath the inequality. So that is a solid dot at -2. And once again, is this saying x is greater than -2 or x is less than -2? X is greater than. It's opening up to the x, so x is greater than. Now, which way is greater than? To the left or to the right? To the right, right? So what we see here is, and I could already get rid of this, let me move this box out of the way. What we see here is the graph of the compound inequality that's written together, okay? Let's compare it with example 1 up here. Notice how this compound inequality, in a sense, it was like two of them separate with the word or, and you ended up with two areas that were apart. And this one was a compound inequality written together, right? This one was separate with the word or in between. This one's written together. You still had to look at it as two different inequalities, but when it's separate with the word or, the areas are going to be apart. Now you can think of it this way. Which way is the inequality going? It's either going that way or that way. Yeah? Now this guy that's written together, the areas are together. Okay, so we need to understand that fact. When they're separate with the word or, the areas are going to be separate. When it's written together as a compound inequality, it's going to be an area that's together. And technically, they could also throw the word and. Instead of word, they could throw the word and that does mean that it's together. Okay, or means it's apart, and means that it's together. Okay, so that's what I kind of explained down here. And you're going to have to fill in the notes. The printer didn't print the actual graph, so go ahead and graph those next two number lines. Important, if the areas of the inequality are apart, you must write the inequality apart with the word or. I'm right here. But if the areas of the inequality are closed, in other words, they're pointing towards each other, then we must write the inequalities together with the x in the middle. The smaller number has to be on the left side, the bigger number has to be on the right side with the appropriate symbols. So not only do we need to be able to graph compound inequalities, but we need to be able to look at the graph of the compound inequality and write them as a compound inequality. Okay? So I think I forgot to close the parenthesis up here. Anyway, let me ask you this. Is this area together or apart? Together. So I know I need to write my inequalities together as a compound inequality. Does that make sense? Mm-hmm. If the areas are apart, like on this guy, then I have to write them apart with the word or between it. But these areas are together, so I need to write it together as a compound inequality. Now, a lot of people freak out with this, but it's really easy to do, okay? Because it's already on a number line, then it's already in order. The smaller number, -2, is already on the left side. The bigger number 1 is already on the right side. So all I need to do is put an x in between them. So this is what I'm going to do. I want to just, like I just said, the -2 is already on the left side. That's a smaller number. Let me write -2 on the left side. The +1 is on the right side of the number line. Let me write +1 over here on this side. And I'm going to put an x right in the middle. Now, all I need to do is fill in the appropriate inequality symbols that belong in between the x and the 1 and in between the x and the -2. Now, check it out. If they're in order, which they are, then the number on the right has to be greater and the number on the left has to be less. You guys agree with that? So, I'm always going to have to put less than symbols. Okay? Now, the only difference is that this one's open, so at -2 I'm not going to have a solid line underneath it. This one's closed, so I'm definitely going to put a solid line underneath it. Now you're probably thinking, why am I always going to put less than symbols right here and right here? Like I said, if it's in order, which it is, because it's always on a number line, the smaller number is always on the left, the bigger number is always on the right, it has to open up to the bigger number, right? And anything that's on this side, it can't open up towards it. So that's why it's always going to be less than symbols. Now, what does this compound inequality really say? It says x is less than or equal to 1. So here's 1, it's to the left. And this is saying, if you read it backwards, reading from right to left, it says x is greater than negative 2. So here's negative 2 greater than to the right. Does that make sense? So when the area's together, you simply put x right in between the two numbers that you're talking about. So you put x right in between the two numbers, and you put less than symbols, and just determine if it's an open dot or closed dot and fill it in appropriately. Solid line if it's a solid dot. That's how we got this one. No solid line if it's an open dot. Now, that one's the only kind of confusing part, but it's not confusing, I don't think. This other one's super easy. Let's take a look at what does this say? If you were to ignore, let me see. If you were to ignore this graph, what does this guy say right here? X is greater than to the right. Is that going to the right? Less than or equal to, because it's a solid dot, less than what? Negative 3. Okay. So now let's cover up the other one, and let's focus in on that one. What does that one say over there? X is greater than 0. That's right. Now, because both of these graphs are on the same number, because both of these, something's happening. I can't move that red box anymore. Okay, it doesn't really matter. Because both of these graphs are on the same number line, then we need to write it as a compound inequality. But the thing is, the areas are apart, so I need to keep these guys apart. All I have to do is put the word or right between them, and that's my answer right there. So let's move on. Please follow along with me right here. It says solving a compound inequality is exactly the same as solving a regular inequality, but instead of getting the x by itself on one side, you want to get x by itself in the middle. So notice, this is what we're used to. Let me use this box right here. This is what we're used to. The inequality 2x minus 4 is less than negative 2. We could all solve that, right? How would you start solving that? Let me zoom in even further here. How do we start solving the plus 4, right? Now, if this were a regular inequality, you would go plus 4 and plus 4, and you would keep going from there, but we know it's not a regular inequality, it's a compound inequality, so it's no longer what you do to one side, you do to the other side. It's what you do to one side, you do it to both outside sides. So if you add 4, you have to add 4 here and out here on this other side. So we're going to add 4 over here also. So my new compound inequality becomes negative 4 is less than or equal to 2x is less than 2. Now we're almost done. We still need one more step. What's my final step here? Divide by 2. And what you do to one side, you do to both outside sides. So you're going to go divide by 2 over here and divide by 2 over here. Now notice, I'm not dividing by a negative, so I don't have to worry about flipping inequality symbols, right? So my middle term is now x. It's finally by itself. I bring down this less than, that's a 1. X is less than 1, but don't forget that there's also this left side of the compound inequality. So bring down that less than or equal to symbol with a negative 2 on this side. And ladies and gentlemen, that's our answer. Now, if they were to ask us to, actually they do ask us to graph it, it says solve and graph. So we have a number line right here. Negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3. Okay, and let's graph this compound inequality. So let's focus in on one side at a time. This says, even before graphing, is this area going to be together or apart? You already know it's going to be together, right? So you could go to the value of negative 2. The value of negative 2, is that going to be an open dot or a closed dot? Closed dot. So let's fill that in. The value of positive 1, is that going to be an open dot or closed dot? Open. All right. Now we already said it's going to be a closed area, so you could just do that. You're done. Now, how does this really make sense? Well, it makes sense if you cover this side up and you say, okay, x is less than 1. What does that mean? Oh, here's 1, less than's to the left. So to the left. And then if you cover this side up, If you read it backwards from right to left, it says x is greater than -2.